Hello and welcome everyone to this episode of The Chocolate Life Live. My name is Clay Gordon. I'm the creator and the moderator of TheChocolateLife.com. And I want to welcome today Bhavani, Veerapaneni. I hope I'm pronouncing that properly. I normally just use Bhavani. So welcome,
That's
Bhavani. How are
perfect.
you today?
Thank you. Thank you so much for having me. It's a great to be here.
It's my pleasure to have you. You know, obviously, I've known you for quite some time. We've had conversations all over the place. From Amsterdam to Seattle to New Jersey, and about what it is that you do. But what I wanted to do before we start is to say to everybody, if you're watching today live, please send me a comment. So whether we're looking at YouTube, LinkedIn, or Facebook, send us a comment. And by sending any comment, you will be automatically entered into a drawing for a premier 8-pound chocolate refiner. You don't have to do anything special, just put in a comment. And I can tell you that if you enter more than once, you only get one shot at it. And we will be drawing for the premier before we end today. So just wanted to let that know. Please send us a comment. And while you do that, please also tell us where you're connecting from, so that I can put it up on the screen. Hey, Thomas is connecting in from New Jersey. Hey, Thomas, thanks for connecting today. We've got Mark and Yuri from Blue Spruce in Denver who are connecting today. You guys have just been entered into the drawing. So yeah, thank you for that. And thank you just generally for your support. So Bhavani, what I wanted to do today was to catch people up on a little bit of the history of Diamond Custom Machine and melangers.com, and also to have some conversations. I mean, I thought I knew how melangers worked, and when I was there, I learned that some of my understanding was not quite up to snuff. So, okay, let's do that. So what were you doing before you started Diamond Custom Machines? What did Diamond Customs Machine start out to be and do? And then when did you decide that what you wanted to do was transition into offering machines for making chocolate?
Right. Before, I'm an engineer by trade, and I used to work for a company called Convatec, and they were part of kind of Bristol Myers Squibb. They were a medical device division, and there I did a stint, I was there for about 17 years, and I did my rounds. I started in package development to R&D to manufacturing. And then when I finally left, I was in global marketing. So I got a roundabout view of how products are made, starting from design and development through manufacturing and all the way into packaging. And I also was Six Sigma black belt back then when it was famous, that's my background. And in about 2014, while I was working there, I also started a small company with me and my wife, Priya. And Priya has been a big support. She would do all the work, and then I would come on nights and weekends, and we would hustle and try to get something going on the side, because we always wanted to have something of our own, be an entrepreneur, have something of our own business if we could. So we were always trying to do something. And at about 2014, the company moved their worldwide headquarters from New Jersey down to Greensboro, North Carolina. And then now I think they're over in the UK. But anyway, and at that time, I left the company and I started to work on our little business that we started back in 2002 on a full-time basis. And it's a very interesting story. And people keep asking me all the time, how did you get into chocolate? What's the story, and how did this all happen? And it all happened because I got a phone call from a guy named John Nancy, which you probably all know. And John called me up saying, yeah, I need some parts for Premiere. And I was like, what kind of parts do you need? And he told me a list of parts. And I said, we never sell those parts to anybody. Mm-hmm. And I was like, what do you do? And he said, if I told you what I'm doing, then you probably wouldn't give me the parts, because I'm not using it for the intended use of the product. I'm kind of putting some things together. And I said, how about this? How about you tell me what you're doing, and then I'll give you the parts for free. And he said, I'm making chocolate. I said,
Mhm.
it's so interesting because a lot of customers come and buy these machines for chocolate, and we know they're using it for chocolate, but I had no idea
Mhm.
what they were doing with it.
Mhm.
So I told John I would come and meet him in Portland in Oregon.
Mhm.
And then I flew out there. I met with him. We had a great chat. And then he gave me a few ideas on improvements. And that's how my journey into chocolate started.
Mhm.
It was all timing. I
Mhm.
was looking to do something, and John's phone call came in, and it was just, and then from there on, Greg from Dandelion has been
Mhm.
awesome.
Yeah.
I went and saw him after that, and
Mhm.
he was the one. He didn't know anything about me, but he knew I was somehow related to Premiere, and he was the one who was kind enough to spend a lot of time with me and say,
Mhm.
what are the problems with the existing grinders that are out there in the
Mhm.
market, and what's needed, what needs to be done. And that started the whole thing about, okay, what can we do and
Mhm.
where do we take this? And coming
So if
from
I
an
so if I
engineering
can
background.
jump here, so I can jump here
Yeah,
quickly. So you introduced your first chocolate specific product in 2014 or thereabouts. So by
correct,
that time, there are two really, really established players. That
correct,
would be obviously Santa, now Spectra Plaza,
correct,
and Cocoa Town. I
correct.
don't want to. I want to focus on. So when you thought about, what is it that is missing, right?
Right.
So that's determining what direction you're going in terms of what our product's going to be doing. Do you remember some of the sort of high level responses that you were getting that said, we wished our machine would do X and we wish our machine would do Y, that informed the way you came to design your first machines?
Right. I mean, one of the first things that people were talking about was everybody was tired of the chains and the belt drives. They wanted something that was a direct drive and that was maintenance free in the sense because with the belt drives, the belts were breaking or they were slipping, the transmission power wasn't always uniform. So the refining efficiency was not always consistent. And the other problem was with the change was the noise, So they were saying, can you get us something that's more of a direct drive? And that was one of the big user requirements that was out there back then. And the second thing that was out there was, can you make something that was more reliable,
Mhm.
um, that we can get a machine in and run it day in and day out and be the heart of the machine? Because one of the things that was, if you remember it, even now it's true to some extent, is from a chocolate maker standpoint, you're not just a chocolate maker, but you're also a little bit of a mechanic. You're fixing things, you're making things right. And there's always this element of trying to make things work. Now, coming from an engineering background, my goal was to see to that how do we make these machines more reliable? So it doesn't have to be fancy, but reliability was the key. So you can rely on this machine to work in and day out. So how do we do that? So that's how we started it. And when I started, I used to work with a good friend of mine called Ken Johnson. Ken is an R&D engineer, and we worked together on many projects at the device company that I was mentioning. And I remember the first time we were trying to hook up a few things, and we had it on a table saw. And we put it up together, we wired it up, and we were like, is this thing going to blow up? We had no idea, but we were trying to. So it was many hours of trying to figure out, what works and what doesn't work, and how do we put it all into a package where it can be reliable and it can work day in and day out. That's been our main goal from the very beginning.
So let's
And
talk a little. Let's, if I can, let's talk a little, because
yeah,
we had this conversation at length.
right,
Is that one of the things that you've done is you've sourced what are called DC motors. So these are
right,
direct current motors to drive these things. And one of the reasons why you're doing this is that they are more energy efficient
right,
than an AC motor, or running an AC motor through a power supply of some sort in order to be able to do things like get a speed controller capability on the machine. So
So
can you talk about, the differences in motors and how being a direct drive as opposed to, say, an offset, and how that might affect gearing and all this other kind of stuff, which are all components of things like drum rotational speed and consistency over time. And then if you've got a motor, I mean, I see this little machine that's to your left, which is the
right.
new DCM 15. And one of the things you told me about this machine is that it is more energy efficient than the smaller Premier 8 and 10 pound machines, which seems counterintuitive. But how does that actually happen?
Right. So one of the goals was, trying to see how do you make these machines efficient, right? So, and the way to do that is, designing the machine so that the machines are running based on load. So there's intelligence built into these machines, right? So when you look at the DCM 15, what we did was we put a DC motor in it, and it's got a frequency drive that drives it. But these DC motors will only consume the power that they need for them to do the work that they need to do. So most of the machines that are, if you look at the ones that are traditional grinders that are out there, are all, you turn it on, you flick it on, it's like a flicking a fan on. They consume at a certain speed and they consume a certain amount of power. And that is an issue, and
But if
so
I can jump in there quickly, is that so a base zero load, right, is they're consuming a fair amount of power. But that
correct,
the more you add to the bowl, the greater that
right.
power consumption becomes.
Correct. So, for example, if you look at our small Premier, it's a basic induction motor. And when you flick the switch on, it's going to consume 2 amps of power. It's 200-watt motor at 110 volts input. It's going to consume 2 amps no matter what.
Mm-hmm.
But when you flick this switch on a DCM 15, it knows the loading that's happening on the drum. And then it varies the current draw based on the process cycle that the machine is going through.
Mm-hmm.
So typically DCM 20 is one of those machines that we put out. So customers will tell us, hey, the DCM 20 is actually, my electric bill went down because I stopped using the Premier and I went to a DCM 20, because DCM 20 consumes probably about an amp, and it's producing about 25 pounds of chocolate. And these Premiers are producing 8 or 10 pounds of chocolate. I mean, it's all price point because now the electrical components are more expensive. So everything drives up price. But what you get for that is your efficiency. The machines are running cooler, because when you look at a Premier, when you touch it on the side, it's warm to touch.
Mm-hmm.
And these machines, when they're running, they're cool to touch. They're not as warm as the Premiers. And that's because you're losing a lot of your efficiency in form of heat.
Mm-hmm.
Those kind of things are happening with a regular smaller refiner compared to some of these newer ones that we've been building.
Right. So I think one way to think about that, for
Mm-hmm.
people who are watching, is that when you're looking at the cost of a piece of equipment, you have capital equipment expenditure, you have the actual cost of the equipment, and then you have components which feed into what I think of as total cost of ownership. And so
Right.
historically, over the last year or so, energy bills are much higher than they have been in the past. And so
Correct.
if you can reduce your energy usage on a machine by 50% or more, what you're doing is you're reducing the total cost of ownership of that machine, and you're consuming energy more responsibly. If we can,
Right.
we can go and do that.
Right.
So, but one of the things I think that because you're using the DC motor with a variable frequency drive, you've got, people can't see it on the front of the machine that you've got there, but you have the ability to actually vary the speed of the drum, right?
Correct.
Sort of at will. So you and I had this conversation. Right now, I think the display shows you the RPM of the motor. I wish it could display the actual RPM of the drum. And, that's, I don't know how much of a software tweak that is. But one of the questions I had was talking about with Mark at Blue Spruce Chocolates over the weekend is, how does, why would I want to vary the drum speed? how what does that do for me or for a
I
chocolate
mean,
maker?
number of things, right? I think, a lot of the custom, I mean, we see situations where someone's making white chocolate. So
Mhm.
it's all fluid, it's all liquid, and it's moving. And sometimes, when they're running a higher quantity, it tends to slosh around because with Premiere, it's one speed. So we used to get pictures and videos of stuff like, hey, we got the spray going around. We're like, yeah, you have viscosity issues and it's too viscosity is very high or low, and that has an impact on what you're able to refine in the machine. But if you have a machine that you can adjust that, so if you see that you're running something that's very low in viscosity, then you can reduce the speed so you don't have the splatter. Whereas with Premiere, you don't have that choice. You end up with splatter. Or sometimes what happens is customers will tend to run very low quantities on a very big bowl. And when they do that, the stones tend to pick it up and do a whiplash. It's like a whip, they pick it up and then they whip it. And then when they whip it, as they're spinning, and if it's a constant speed, they're going to spin it all over the place and it'll spin on the brim and then outside the perimeter of the machine and into the room and everything. So then we tell them, hey, there are ways to work around it. But if you have the ability to control the speed,
Mhm.
then hey, I'm running this low quantity and also low viscosity product. Then I can change the speed and not have all these issues.
So is there a direct correlation between bowl speed, which is going to be affected by the pressure that the stones are, and the temperature of the chocolate? So generally, the faster the bowl is spinning, the higher the temperature the chocolate is.
Right. So it's all friction, right?
Mhm.
Friction is where the temperature is coming from because so the contribution to friction is your bowl speed and also the pressure of the stones and the ingredients themselves.
Mhm.
The ingredients, depending on your ingredients, you would have higher or lower amount of friction, right? So, and you can vary the temperature of your chocolate by increasing or decreasing the speed. That's a very good point, right? So if you want to decrease just temperature and not run it at a very high, we have a lot of customers who want to make raw chocolate or who want to run the ingredients at less than 118 degrees Fahrenheit. And when you want to be able to do that, there's only a few things you have in a fixed speed machine. With a variable speed machine,
Mhm.
you have more levers to pull
Mhm.
to adjust to make the recipe that you
Right.
want.
Thinking about raw chocolate,
Hmm.
we're going to get to this question, and then I'm going to go put some comments up on the screen. But thinking about raw chocolate, have you ever? Do you think there's any way to actually measure the temperature of the chocolates or the instantaneous shear pressure of the chocolate under the stone at the grinding face? Because if you can get the chocolate up to 118 degrees Fahrenheit or up to 125 or 135 degrees Fahrenheit, the temperature has got to be above that point in order for it to. I'm thinking. Am I misunderstanding something there?
No. I think there are multiple ways to measure temperature. One of the ways we measure temperature right now is using a rapid refiner, and it has like two temperature probes, and one probe actually sits inside the chocolate, and which is reading temperature real time. It's not a surface infrared, but it's a temperature that actually feels the temperature, and you can set it up so it's almost at the bottom of the stone, just above it. So it's not touching the stone, but it's just above it. So you're measuring what's in the belly of the beast. You're measuring it all the way into the belly where the action's happening and you're getting the temperature at that point. And you're able to accurately know because there's always some instrumental error, but within a few degrees, you'll be able to know, hey, my chocolate that I'm producing right now is at this temperature.
Gotcha. All right, so I think that's a great place to take a really quick break. I want to welcome the people from Encore Coffee Company in Missouri for joining us today, and to let people know that all you have to do to enter the drawing for a Premier 8-pound Melanger is to throw a comment, whether you're watching on YouTube, LinkedIn, or Facebook. Just throw a comment. I will see your name. I will see where you're commenting from, and that will enable me to follow up. Afterwards, we're going to do the drawing at the end of the hour, and everybody will know who the winner is before the end of the live stream. But just put a comment in and let us know. So we also have Jim Benton from Chalice Chocolate in Fallbrook, California. And then he says a lot of it started from John Nancy. Absolutely, absolutely, yes. I think of John as being perhaps one of the most influential, if not the most influential person in the craft chocolate movement. He's the guy who pioneered this small production pathway based on what were originally Indian idli grinders. So yeah, absolutely. And then Mark saying, "What a small world." He never knew about that connection. Again, talking about the connection between you and John as you were starting the business up. So, I mean, for me, this is all fascinating. So I was aware to some extent that, because of the work that I've been doing with motors for FBM tempering machines, that the kind of motor you're using does have an effect on overall efficiency. And so we focus on that. And that there was a direct relationship between the speed of the bowl and the pressure of the stones, right? But what I want to talk about is we had this really, really fabulous conversation right when I arrived about the notion of precision, right?
Mm-hmm.
And how pressure, right, contributes to particle size and mixing and all that kind of stuff. And I think that one of the things that I thought was most fascinating is the notion that the grinding action that's happening in the melanger is not necessarily, at the contact point between the stones and the stones in the base. One would think that that's where most of the refining is getting done, but it turns out you say that, nah, that's not where most of the refining happens. So please, all right, let us know, how that works.
Yeah. So one of the, when people think of stone grinding, they think the stones are the ones that are grinding. It's the work. The stones are what's grinding the particles. Actually, you got to think it in another way. You got to flip it around a little bit. What's really happening in a melanger? It's not the stone to stone grinding, but it is in between what's happening between the stone and the stone. You don't want the stone to stone to be grinding. So if you see some really good chocolate makers, and if you go look at their stones 5 years after they purchased it, it'll be as if it was brand new when they just bought it, because they know what produces the best chocolate, and that is, if you look at what's happening inside a bowl. I mean, in the beginning when I first started this, I used to see some of the machines that are out there, and the wheels would not even be spinning, but the chocolate is continuing to refine. I would be like, what? The wheels are not even spinning. How is it continuing to refine? So what's actually happening is, you have the roller stones that are spinning this way, and you have the bed stone that's spinning this way. So the particles that are closer to the roller stone are going this way. The particles that are closer to the bed stone are going this way. And the centrifugal forces are pushing the particles across. They all want to go to the outside of the bowl, right? So now you have a number of different motions going on. And when that happens, what's happening is there's shear. It's like, you grab something and one person wants to go one way, another person wants to go another way, another person wants to go another way. What happens is, and this is happening on a repeated basis, and it has no other choice but to break down. I saw a great Japanese chef one day, and I saw him sharpening a knife. It's a beautiful Japanese knife, and he was sharpening it. And guess what he was sharpening it on? He was sharpening it on a stone, right? So the discussion I had with Clay was, when you're trying to make a product, like a machined product, what do? You always have a higher precision machine. So if you want a machine product, you use a CNC machine to produce a higher precision product. Or
so the idea being, if I can, is tolerances. If you need a tolerance of 100 micrometers, the machine itself probably has to have a tolerance of 10 micrometers in order to be able to do that. So there's a sort of bootstrapping thing. In order to be able to have a precision at some level, I need to be able to have a higher precision machine to make it. And what's really, because the thing that started this conversation was I was going, is there any impact on bowls that wobble differently. Every single one of
Yeah.
these bowls wobble. None of them is straight. And I was wondering if a bowl that just really, really wobbles eccentrically, right, would produce a different chocolate than a melanger that is right next door, right,
Right.
that has a very different wobble, right? And what you're saying is no, right? That what matters here is the fact that there is, well, what matters is efficient mixing. What we
Right.
need to do is
So
we need to make sure there's enough turbulence and flow in the chocolate so all the particles are beating up against each other. And it is the beating up against each other which is doing the refining aspect.
correct. So the
Okay.
refining is actually happening because they're grinding against themselves.
Mm-hmm.
You know, to talk about that example that we were just talking about is like to cut a diamond, you need another diamond. You can't use a stone, right?
Mm-hmm.
So, but if you're looking at the sword, like a very sharp a samurai sword or a Japanese kitchen knife or any of these very beautiful things, and they're polishing it on a stone. Why stone? Because the thing is, the amount of pressure that's being applied, it's not too much, it's not too little. It's a right. It's like playing an instrument. You see this chef using it, and it's rhythmic. It's moving in a certain motion. It's at a constant pressure. And guess what? A surface of the knife just keeps peeling off, and it creates this black little, like a little fluid. And he uses that to grind it even further. So he's using the shavings of the knife itself to keep the knife sharpening. So it's the same concept,
Okay.
and that's what the stones do, right? The
Mm-hmm.
stones provide that medium. So that's why we keep telling our customers, don't put too much pressure. It's like, again, playing like an instrument, going back to that example, you got to put just enough pressure, not too much,
Mm-hmm.
not too little,
Mm-hmm.
but just enough where you can keep this motion going,
Right.
and you will be able to reduce the particles beautifully.
Right.
Because what's happening inside a melanger is it's the environment itself that the chocolate is in, or anything that's inside of the melanger. It'll just grind it down because of because of the environment that it's in. It's not because of stone, but it's the environment that it creates.
It's not just the stone, right?
It's not just the stone.
So what this says is that, for example, if I am in a small melanger and I
Uh-huh.
have the ability to position the wipers, right?
Mhm.
I may actually move the wipers to a place where it's less efficient in terms of mixing,
Uh-huh.
right? And so
Yes.
I could, after taking them off for cleaning or something like that, put them in the wrong place and then notice all of a sudden, oh my gosh, it's taking longer for my chocolate to refine than it used to. And it turns out
Right.
that the size of the blades, the position of the blades, I think you also mentioned that the angle of the blades, right,
Right.
in terms of contributing to the turbulence is
Correct.
an important thing. So when we think about, like lots of things in chocolate, the answer is it depends. And things are usually a lot more complicated than you think. Something as
Right.
simple as what does the wiper blade look like and where is it in the bowl is
Right.
something that, requires, listen, computational fluid dynamics, right, at some level to be able to understand what it is that's going on.
It's one of the things that blew our mind is this one. We have on our little premieres, we have like a plastic stone holder, and it works really well. But the problem with it is it breaks because of the stresses. It can't take it. So we went with the stainless. But with the stainless, we designed it such a way that one of the drawbacks of plastic was it was not only that it was breaking, but it was also having like an Archimedes screw effect. So if the tolerances vary between the center cone and the plastic holder that goes in, it starts to pump the chocolate and you go into the machine. So what we did was with the stainless, we just went with two pieces of metal. So that effect of the Archimedes screw is gone. It's no longer there. Also, what happened is it created a lot of open space inside the bowl. Because of the open space, now what we're seeing is the refining is happening. What people are telling us is about 10 to 20% efficient refining. Because now talking about the environment that this bowl is created is changed. The flow dynamics have changed, and the refining efficiencies have increased. So yeah, you're absolutely right. In that thought process, yeah.
Right. So there's something I want to tap into. There's a really, really fascinating question from David Briseño, who's connecting from Colombia. And before I get there, I want to point out that one of the things that you mentioned is that it is possible to put too much pressure on the stones. People think that you need a lot of pressure in order to be more efficient. And it turns out that there is a point at which there can be too much pressure. As a judge, right, at the International Chocolate Awards and other places, I often taste chocolate that feels and tastes like it has stone in it. And so one of
Yeah.
the things that I tell people that they should do is they should lick their stones. Just take a clean, dry stone, put your tongue on it, right? Lick it. And if you ever taste that in your chocolate, that's one signal that you've got that you're applying too much pressure. And you may not see it right away, but if you see that what you're doing is you're refining grooves into the base stone, where is that? People talk about, I don't want to do a ball mill because I'm worried about there being metal in the chocolate. Well, at least the balls are made with some magnetic medium and you can pull the metal out of the chocolate. But if you're doing stone ground chocolate, there's no way to filter extremely small particles of stone out of your chocolate. I don't know. Have you ever licked the stones?
No. I mean, that's a great point, right? I mean, so people question us all the time, like, hey, what happens to the stone? What happens when I ingest the stone? The good thing about the stone is it's not a metal, right? It's silica, and it pretty much passes through the system. So whereas metals, they tend to stay in your body, they don't tend to leave. And if you look at the human evolution, so FDA has this classification of what is generally considered safe materials to use, and stones are one of those materials. And that's because we as humans evolved by using stone for millennia.
Well, I'm talking about contributing to particle size and texture.
Oh yeah.
So I'm not talking about food safety,
right?
Which is another issue entirely. I'm talking about, there are times when I've tasted chocolate that there is a grit in it. And because there is a particular flavor associated with it, I'm going to go, oh, this has been in a refiner for somebody to put too much pressure on it. Yeah, because you can taste it. Right. I do know, for example, that when Taza was looking to import some refiners from Oaxaca in terms of their chocolate making process, they were allowed to, right? But they couldn't actually import the chocolate from Oaxaca because the chocolate had too high a residual component of the grit from the grinding stones. But they were able to do it here in the United States. It was an import issue. It becomes an issue at times, and something to consider. What I do want to do is really briefly, we're about halfway through the hour. I want to say hello to Keith Ayub. Keith is a regular visitor here. He's a contributor to The Chocolate Life. He's got a number of articles going on. He says he's not a chocolate maker. He'll happily give it to one of you. Keith, I think you and I have talked about your love of peanut butter. So I think that if I'm correct, you could actually use your refiner to make your own peanut and other nut butters and things like that in your home. So thank you very much for the offer if you win to donate to somebody. But we'll keep that on the table. Thank you very much. As I mentioned, David from Colombia has an interesting question. So Bhavani, he says he's always heard that progressive refining is better than trying to achieve size reduction too fast. Is it possible to gradually and repeatedly increase shearing and achieve a progressive size reduction with a refiner of this type?
Yeah, I mean, with this type, the default is it's progressive. It takes a long time to refine. Like, for example, when you're trying to make, refined chocolate on a small premier, it takes about 8 hours to bring down, 8 to 12 hours to bring down a particle size. On a larger machine, it can take longer. It is a gradual reduction. It's not like a blender, right? With the blenders, you're looking at the speeds of 22,000 RPM and things like that. Whereas the machine like this, you're talking about 100 RPM. So with the RPMs being so low, it just takes a while. And that's why, it's not a fast process. It's a very slow process, and it takes hours and days to make good chocolate because it is a progressive process in how it refines chocolate. I hope I answered your question. But
so I want to see if I can expand on it. Right. And before I do that, I want to say hello to Scarlett. Hey, Scarlett, thank you very much for joining us today. I saw that you signed up as a member of the Chocolate Life this morning. So thank you for signing up as a member. I appreciate that support. So What I would like to say to David is that it's important to remember in the chocolate making process that what takes a long time to refine is the sugar, right? If you just put nibs into a refiner, you can get a very, very fine liquor relatively quickly, in under an hour in a small premiere. But the rest of the time is really about, okay, the sugar. Now, so it turns out that the particle size of the sugar and the amount of sugar in the recipe is partly the determining factor of how long it takes to refine. Now, what you can do, and many people do, is they will put a pre-refiner into the process. So I could have, for example, a burr grinder, a stainless steel burr grinder. And what I'm going to do is I'm going to try to take the particle size of the nibs from 3 millimeters down to 100 to 300 microns very, very quickly. And then what I can do is I take the sugar and I can refine it into the liquor so that the sugar is about the same particle size, right, as the cacao particles. And so when I put them in, I've reduced the amount of time it takes in the refiner. So that is one way to do it. It's how a 5-roll mill works, for example, or a 3-roll mill. The gap between two of the rollers is big, right? There's an adhesion, so the film, the suspension creates a film between the rollers. It gets dragged through the next gap, which is slightly smaller, and then it dragged through the next gap, which is slightly smaller. So that's a way to do this progressive refining very, very quickly, right? But now what you're talking about is another machine, right? And you have materials handling issues. I have to get the stuff from one machine into another machine, right? And so there are trade-offs there in terms of cost, right, and time and labor. I mean, one of the great advantages of the melanger approach is that once you get the ingredients in the melanger, for the most part, you can walk away. You don't need to pay attention to it. You're not picking up ingredients and you're moving them from machine to machine to machine. Whereas if you're doing a progressive refining approach, which involves multiple machines, right, you've complicated things. I personally think that having a 3-roll refiner, right, is especially one which has got stones as opposed to stainless steel rollers, is good because it gives you an opportunity to experiment. And you can also things like create gianduja and other things very, very effectively and very, very efficiently. You can use it in a lot of different ways, and you can play with the order in which you do things in order to be able to achieve different results. I don't necessarily, I wouldn't recommend it as a replacement for a melanger, but it can be an interesting complement to a melanger for just those purposes. I don't know. I mean, do you have customers, Bhavani, that you know of who are mixing and matching different kinds of equipments in order to be able to play with, number one, refining efficiency or to achieve different finished results?
Oh yeah, we know a few customers who use like a peanut grinder to grind it down to a paste, and then they take that paste and add it to a melanger because the loading is a lot faster. Because instead of trying to add nibs, which could take a lot longer, you pre-grind it into a paste and then you're just moving it on. Or using like a cutter mixer. That's another option that I've seen people use a lot. And the other option I've also seen is people, like you mentioned, Clay, is a 3-roll mill or a 5-roll mill and getting the refining done very quickly. And then they use the melanger to agitate it and to get the conching effect of getting the flavor. So the refining is not actually happening in the melanger. Refining is happening on a 3-roll mill or a 5-roll mill. And then they move it to the machine for the flavor development. So I've seen that happen. So everybody has their own little process that they come up with that they think works for them in their environment. And I've definitely seen that. And I've also seen people using a small blender, and they blend it into a powder form. You take the nibs, you put it in, within a few seconds, you have a powder, and then they load the powder in. Along with some powdered sugar is another thing that they do. So there are all these different options that people have come up and figured out. Yeah.
Right. So, but if I would just to let people know, if you are using powdered sugar, do not use commercial powdered sugar that has an anti-caking agent. It often has
Mm.
cornstarch or something like that. You do not want cornstarch in your chocolate. If you're going to be using a powdered sugar, make the powdered sugar yourself just before you add it into what's going down. And there are people, I know I've had conversations with people who said that they go the other way. They like using larger particle size sugar because it turns out that the initial crack, right, it makes the particle size reduction happen. I know it sounds faster. I know it sounds counterintuitive, but I understand, how that might be the case. The point is experiment, right?
Right.
And one of the contributors that you really do need to worry about with sugar is the moisture content. The higher the moisture content, the harder it is going to be to do anything in terms of that. So what I want to do, if I can, I want to recognize Keith, who is a specialist, had a career in pediatric nutrition, I believe, at the Albert Einstein College of Medicine, who's, again, been a guest. We've been talking about cadmium and lead and chocolate and stuff like that. He says his contribution to the conversation regarding the silica from the guiding stone being a health issue, it's not likely, right? So yes, it should pass right through. Now, it turns out that metal should not be an issue because if you're using a metal on metal system, whether it is a ball mill or a universal or a 5-roll or 3-roll or 5-roll with steel rollers, is by law, you would be required to have some mechanism, probably a vibratory screener and a magnetic trap, in order to make sure that any metal which might be in the chocolate from the refining process is screened out in advance. And as you might guess, many larger manufacturers will also use a metal detector after the product is finished and wrapped, so that if there is any metal detected, it gets kicked out. Not a whole lot of small chocolate makers have the resources, right, in order to be able to do all those things. But from a food safety perspective, it's really, really important. We have Chocolate Gutta, excuse me if I'm mispronouncing that properly, agree that moving chocolate between two machines is an extra step for some people might make the whole process harder. But if both machines combined work a lot faster than a melanger on its own, it's worth looking into. So, Bhavani, I don't know if you have anything to add to
Yeah,
that.
I think it's a very good point. But there is one thing I always like to tell people when they meet me, when they say, "How long is it a process?" I would say it's about 2 to 3 days. And they say, "Oh my God, it takes so long." And I tell them, good things in life take time. There's no point rushing through things sometimes. Sometimes you just have to wait, And what we found is when the time is given, the acetic acid, the volatiles that need to go out of chocolate, they take time to get out of it, and sometimes it does take time. Even if you're running through a, ball mill or whatever, and then you still have to conch it on a conch, you still have to run for a day or two to get those acids out to get
So here's a contribution that I will make, is
yeah.
that from my experience, for people who don't know, I convinced FBM to deliver a small craft size conch, specifically designed for craft chocolate makers, called the Kligo. The Kligo is named after me. So KLEE is a painter by the name of Paul Klee. So that's where the Clay comes from, and the Geo is Gordon. So the Kligo is named after me. And one of the things that I learned, and this is something I learned from Ed Seguin, is that acetic acid will evaporate out of the chocolate while there's still water in the chocolate much, much faster. So one of the things that you may want to consider is getting the chocolate to 55, 60 degrees very early on in the conching process, or in this case, the refining process, because the acetic acid will evaporate out very quickly. Once you can no longer smell acetic acid, drop the temperature, right? But you're absolutely right. So what we did is we found, in terms of acetic acid, we found is that we could take what normally took about 2 days, and we could do it in 2 hours, right? We could conch a chocolate flat, get rid of all the volatile aromas off it. If we just kept the temperature up at 60 degrees over the course of 2 hours, it would be gone in an hour, right? Just like it would be, bleh, right? Just completely flat. So you do have that. Because there is less, digitally precise control over the temperature in an open vessel like the melanger, you need to be much more aware of what it is that you're doing. So a device like the Rapid Refiner, which has got a thermocouple in the chocolate, and then a thermocouple which is measuring the environmental, the ambient temperature within the bowl, right, are tools which help you more precisely control that process, right? And if you have a much bigger machine, certainly not a 8-pound machine or a 10-pound machine, right? These things become more difficult to control and much more expensive compared to the price of the brace machine. But I think it's a really, really important thing to know. And what I will say, Kel, who's coming in from Norway, who accidentally signed in from this other account, what I would say is that you take a look at your longest process. If you're in a device that takes 48 hours from beginning to end, right, then what you need to do is you need to make sure that everything that goes into making that batch or everything that comes out of making that batch happens within that 48 hours. So if you can get all your nibs cracked and winnowed in 20 hours, right, that's fine, right? It makes more sense to see it if I could do it in under 30 minutes because the cost of labor is so huge, that differential. But if what you can do is by spending an hour in another device, doing something that will take the 48 hours and then turning it into 36 hours, right, that might be worth considering doing, right? You just need to make sure that the processes that you add take less time than the processes that you're already working with. So absolutely, it's a great thing. Thomas suggests that what he does is he uses a dehydrator to warm up the nibs and the sugar to help things get started, to which I would add, if you have some way of warming up the stones of your melanger before you put things in. So if you've got some sort of fan, some sort of heater that you can use, that you can make sure that everything is roughly the same temperature on the surface. And when you throw the nibs in, they'll tend to liquefy much more quickly, which will be a good thing.
And the reason why, just to jump in, Clay, really quick, the reason why that's very, very important is you need the fat to come out of that solid state and become liquid very, very quickly. As it becomes liquid very quickly, then things start to move in the bowl rapidly and things start to shear down rapidly. And that's why we want to be able to release the fat out of those beans, out of those nibs as quickly as possible. And the sooner you do it, the faster you're able to get it out, the faster the shearing is going to happen. It's the movement. Again, it's the movement of the particles within the bowl, right?
Yeah.
Sorry.
So what I want to do really, really quickly, I haven't done it yet, so I'm going to do it now, is remind people that for every single one of these live streams, what I do is I create a post on The Chocolate Life where you can find resources that you can go to. So you don't need to go through and try to write them down during the course of it. Here's the homepage of The Chocolate Life right now. If you are a member, I want to let you know that you can go and take a look at this post down here, the Chocolate Life member newsletter for December. And there is a link to the AMA conversation, which will happen this Sunday. So you can go there. If you're not a member, what you get is you get something that looks like this. It says, oh, you're not logged in. This post is for subscribers only. And you can sign up. But I am having an AMA live stream on Sunday. You can click on that. This is the homepage of The Chocolate Life right now. There is a post that I created for this live stream with Bhavani. You'll find that we announced the drawing. There's a link to the homepage. If you want to, in the future, go and take a look at this either on YouTube or LinkedIn or The Chocolate Life. The videos will be archived there in the future. So you've got that resource. If there are other resources that are mentioned, we will put them here. And here is the homepage of melangers.com, which is where Premier and DCM machines are sold. So Bhavani, what I want to do, if I can, because I notice they're not on the website yet. And so I think that one of the things that I teased everybody about, all right, for here, let me see if I can do this. One of the things I teased everybody about, now this may be a better way to do it. One of the things I teased is you have two new machines, one of which is in front of you to your left, which is the DCM 15. Now you've got a Premier 10, which is a roughly 10-pound machine. You got a DCM 20, which is roughly it's a 25-pound machine. It's a whole other story. But you've got this DCM 15 machine, and it seems to me, what is the use case for it? Why this machine fitting in between these two other machines?
So one of the things that we've, heard from customers is that, after a while we see that we're selling a lot of parts. Again, it's going into the point of reliability, right? That's the main motto, right? How do we make the machines reliable? And premieres are great. They're great to start out with. Number one feedback we get is they're a little noisy. They get noisier. And then they have wearable components like the belts wear out, the bearings wear out, and the gears are aluminum and they wear out. So the question is, how do you make something that is not a jump from, because the Premiere is about, $300, $400, I can get a machine. But the next machine that's out there is $2,500 or $2,600. So now a lot of people, that's a huge jump, So how do we get a small tabletop machine that's very compact? It's about the same size as a tilting machine, but give it more capacity and get some of those issues that people have been, dealing with over the years and get it off the table. And some of the issues that we've heard, we talked about variable speed control, why that's important. And also the ability to go back and forth, reverse and forward, because sometimes you're loading in components in a nibs in, sometimes it gets stuck. And you want the flexibility to be able to go backwards and flip it, run it backwards so you can release everything.
That's something right now here today you're committing to add to the production machines. The
Yes,
ability
yes,
to reverse.
it will be
on the DCM-15
yes.
first.
Correct.
Absolutely.
It's already baked in.
All right. So are you also going to reprogram the controls so that it shows bowl speed rather than motor speed?
Correct.
RPMs?
Yes, it's already done. Right. Yeah.
Oh, cool. I want to let everybody know that I was at DCM World Headquarters last Wednesday.
Yeah.
Right. Where Bhavani and I had the discussion about those two particular usage issues. And so I'm really, really happy to know that they're going into these first two production machines.
Yeah, we're making it happen.
Okay. So regarding the DCM-15, it's not currently on the website, but you are taking pre-orders for it.
Correct. So we'll have it up on the website next week and we'll take pre-orders for it. Yes.
Gotcha. So if people are interested, you have I think I remember saying it's roughly going to be $1,200.
Correct.
So absolutely. And that would either be for a 120 or 220
110
volt,
or 220. Yeah.
110 or 220 volt system. And great. And when you say compact, I think it's about 30 centimeters by 30 centimeters, right? So about 12 inches by 12 inches.
Something like that. Yeah.
Okay. And so I can imagine the use case, right? Not only because, okay, I have something in the price, I have something in this price point, but because it's quieter and it has this small footprint, we have something that might more easily fit into a retail countertop environment. So I might have one of these things on a countertop, or if I have a restaurant kitchen and I want to be making chocolate in a restaurant kitchen, I have something which is much, much smaller and quieter as well. So those are two other aspects of the machine.
Right. Another thing also, we looked at what are some of the pain points, like, Jim and I had a conversation a couple of days ago about how chocolate gets into the premieres, with the Archimedes screw issue. And we took that out of this issue with this machine. And we also made everything metal, so that's not plastic components wearing out. Even the bushings we're working on, trying to find a material that will last a lot longer than just a plastic bushing. Mm-hmm. So those are the things that are all going to go into the machine. So it's really a production machine designed to work day in and day out. Gotcha. And not having to figure out, hey, can I get a belt or can I get this bearing and can I get the plastic parts and stuff like that.
Exactly on that point, Scarlett asked the question. She's a chocolatier, but newer in the chocolate making world. Why is there an 8-pound machine and a 10-pound machine?
I think the 8-pound machine is a little tabletop. It sits on the table and it doesn't tilt. The 10-pound is a little bit bigger and it tilts. Mm-hmm. So it's got a couple of different features, but the motor component inside is exactly the same. The transmission is exactly the same between the 8 and 10-pound. It just has a few features that are a little bit different.
And what I would also say is that if I'm starting out at the hobbyist level, then investing $300 on a refiner or $400 on a refiner, when I'm not exactly certain that this is what it is that I want to do, makes a whole lot more sense than jumping in and saying, I'm going to spend, as you pointed out, $2,500, which is the smallest machine you currently make on the market. So I think, Scarlett, there are a bunch of reasons why this is the case. And the Premier is also the first machine that you offered. I mean, it's the one that's oldest, predating 2014, right?
Right, and that's where John and everybody else started. Premiers. They were the ones
Gotcha.
that was what was available, in the market. Um,
So I want to talk about one thing more before we get into this. And we've just got, I want to be respectful of your time. We said an hour, we got less than 5 minutes left. But over your right-hand shoulder on the wall is the announcement of another new product, the Breeze Winnower, right?
mhm,
And what I want, so I'm, you and I had an extensive conversation, and people who know me and have followed me know that, that the lack of good options for crackers and winnowers has been
mhm,
one of the most frustrating aspects of what
mhm,
goes on. And that, most of the crackers, which are rollers, which pinch, right?
mhm,
The pinch the beans between two rollers and maybe a third roller where the gap is not adjustable. Some
mhm,
beans are overcracked, some beans are undercracked. So you end up with a lot more fines. So you end up with a lot more usable nib in your shell component. You have trouble separating the shell component from the nib component. You have to take it from a cracker into a winnower, just really, really crazy. And you really do need to think about spending 15, 18, 20,000 bucks
mhm,
for something which might be an impact cracker with a multi-deck scalper and a vibratory screener with vacuums to be able to get where you want. And I got to tell you, I walked in, saw this machine. When they opened up the actual cracking mechanism, I said, I understand exactly what it is that you're doing, right? And I understand exactly why this works. This is
uh-huh,
something that I started exploring with in 2011, 2012, based on a prototype done in PVC plastic at the University of Hawaii, and couldn't figure out how to do it, right? Because it turns out that the geometry of this gets very, very complicated very, very quickly, and there are a lot of
yes.
interdependent geometries. But what I did, just want to let everybody know, is I walked around and completely detuned the machine. Right? There's a vacuum. There's the ability to control the amount of vacuum. It's a little lever. The vacuum right now is being supplied by a shop vac. I'm hoping you'll replace that with a squirrel fan, because competitors at this scale are also using much, much quieter fans. But and then I also detuned the gap. I also changed the gap between the cracker and the impact mechanism, and not thinking about it. I just detuned the entire machine. And you threw a handful of beans, roasted beans, into this cracker, and they came out, and they were among the cleanest beans I had ever seen on a single pass for a machine costing, well, a detuned machine at any price. I mean, it was really, really quite astonishing to me. That the yield that you're getting out, which talks to the cracking efficiency of what it
Mhm,
is that you're doing. And so, again, this is a machine that's in its finished phase of testing. You are
mhm,
taking pre-orders for it. I
mhm.
understand. You're expecting a price point of about 5,000 US
That's correct.
for a machine capable of processing um, 40 pounds of
40 kilos.
40
Yeah.
kilos of beans
Mhm.
into nib and shell.
Yeah.
Did I miss anything?
No, I think you got it right. I think before we lose the hour here, the reason we took the approach of a melanger when we were designing the winnower, we said, how can we let the beans crack themselves instead of forcing them to be cracked? So it's the same thing. What happens? You create an environment where, as the material is flowing through the system breaks everything. So because of that, you have very little amount of dust, and the particle size doesn't matter whether you have a flat, whether you have a thin one, a small one, big one. It doesn't care, because as it's going through the system, again, remember the pressure, the time, and the how it flows through the system. And once you control that, and as it goes through it, it has no other choice but to break.
Mhm.
And it breaks cleanly. And the other thing is, we tend to break the bean with the very big nib sizes, because the bigger you're able to break it, the better your dust is, because there's not any dust at all. It's very dust free. I mean, so there's so many different advantages. I know we're running out of time,
No, no,
but
no, no, no. We, listen,
yeah,
there's no back end for me. I want to be mindful of your time. But what I do want to do is I very quickly want to go and share my screen, right? And what I want to do is I want to go over to um, the place where we're going to do the drawing. I want to say that even though there are currently 26 people who are watching this, only 9 people have commented. So we're going to wait another 1 minute, right? So till 1 minute past 1 o'clock. If you want to throw a comment, whether you're looking at YouTube, LinkedIn, or Facebook, any comment, you don't have to do a code word or anything like that. Just enter any comment. Let us know. We'll get your name. Let us know what part of the world you're connecting from. We have another 20 seconds or so. We'll see the number of entries go. And then what I'll do is I'll click this draw button. And then it's a random, live, real time. It'll cycle through all the people who put a comment into the live stream. And we'll have a winner. And then what I will do is I will reach out to you. I will get the information to you. I will connect you with someone at Diamond Custom Machines, and they will get to you. Now, there is going to be shipping in North America, no charge. Most places in Europe, you can have a 220 machine or a 110 machine. If you're in some sort of literally remote backwater that's 1,000 miles from anything, there may be a request to help with shipping, but otherwise the machine is going to be completely free. Correct?
Correct.
I got it down. Okay. So I talked a little bit extra. The deadline is up. Let's click on the draw button. And the winner is Kjell.
Oh, wow. Congratulations.
So in Norway. Kjell, we'll reach out. I'll connect with you on Facebook. I'll get that information from you. I'll connect you with Bhavani, and you can work to get the machine sent to you. So Bhavani, what I wanted, let me go here because I think it's a better view for you. What I want to say is that I've known you for a long time, right? But you're only in New Jersey. I mean, I'm in Coney Island, which means getting to Penn Station takes longer than it does for me to take the train from Penn Station out to New Brunswick, which is near where you are. But I had never come and visited you, right?
Right.
Seeing the operation, seeing what it is you're doing, realizing that what you're doing is that you're importing the stones,
correct,
from India, but everything else is manufactured here in the United States. Everything is assembled in New Jersey. You're sourcing
correct.
motors in the United States as opposed to sourcing motors in India. I mean,
correct.
It is quite an operation. And I know from our conversation that you spent quite a bit of time with at least one chocolate maker taking breezes, right? And saying, what can we do to improve them?
Right. Boho, Charlie Burke from Boho Chocolate, and Breeze wouldn't have happened without him. Absolutely. He was so patient with us and, helped us along the way. And I would take him a prototype and he would be like, no, this is not good enough. And we would be like going back and forth. And without him, this product wouldn't be here. Yeah, absolutely.
Right. And I also want to point out that one of the things that you and I have talked about is that you're looking to make, so this one, the first one, is at 40 kilos an hour, but you're looking at making a smaller one?
Correct.
So you can take the mechanism and scale it down a little bit.
Correct.
And so you're looking at doing something which will be roughly half the price and roughly half the throughput.
Correct.
Excuse me. And then you're also looking at something which is going to have more than double the throughput.
Correct.
So the idea being that, maybe what you'll do is somebody could have an automatic feeder.
Right.
And they could put 2 or 3 bags. And by the way, if I haven't mentioned it, you also tell me that this cracker handles unroasted cocoa beans.
Correct.
As easily as it handles roasted cocoa beans. So
correct.
For people who are interested in raw chocolate or people who are interested in just producing nibs of one form or another, this is a way that the machine can help expand your business opportunities, I think is the best way to think about it. So that even though there's this 140 kilo machine right now, that new machines are going to be coming um, forward. And I know that you and I had some discussions about little small, user experience points that, hopefully will get addressed before the machines first hit the market. I mean, it's been wonderful to have somebody who is, I go and I say, oh, I look at this and I go, here's a really small, really perhaps inconsequential from a cost perspective thing you might do to make this thing more usable to people. And you're all up in the, yeah, I know how to do this. I can think about what the electronic schematic is in order to make it happen. Yeah, we're gonna do it. And so it's been a pleasure for me to be able to start start this relationship, to be able to have you here today to discuss what it is you're doing. And there's a final comment. Well, we have the comment from Kiel who says, "Thanks for being the winner. We've made his night." Yay! That's a good thing. But the parting comment from Thomas, I think, goes to exactly what it is that I had hoped to achieve today, which not only has it been nice to listen, absolutely, but we have made you think differently about using your melangers. Right?
Right.
Absolutely right. That is what it is. That
It's it's deceivingly a very simple machine, but what it
right.
does is pretty mind-blowing, you know.
Right. So I lied. There is one more question, right? So is the yield on the winner 80% on average? So I'm going to jump in on this if I can. You and I
Sure.
talk about this. So Jim, it will depend a lot on the bean that you're using. So if you're using a wild bean, right? So or beans which are very, very small on average, above 130, 140, 150 beans per 100 grams, the amount of shell on the bean is much, much higher than it is on a bean that's 80 to 90 red beans per 100 grams. And so the yield is going to depend to a large extent on the size of the bean. So that's it, right? What you want to talk about is, what is the percentage of shell in nib? And then what is the percentage of nib in shell, right? And that will get you to the yield numbers. By law, you have to have less than 1.75% shell in nib, right? And you want it, and if you're a big industrial manufacturer, you want it to be as close to 1.75% as you possibly can get it, right? Because it reduces your costs. And if you're a craft chocolate maker, you want to get it as close to zero as possible, right? But at the same time, if you overcrack, what you end up doing is you end up generating a lot of dust, a lot of fines, a lot of small pieces, which are still attached to shell because of cocoa butter, right? The cocoa butter is what glues the shell to the nib. And that ends up in the waste. And one way you can tell that you don't have the cracker set properly is put your hand in the waste product. And if it comes up and there's a lot of cocoa butter on it, your machine is not tuned properly, right? It's that you want it to be as dry as possible, right? So that's something to do. So what I can tell you is that even on a detuned machine, in a single pass, right, the nib that I saw out of this still prototype breeze, there are some things that need to be done. And this is when the vacuum was not adjusted properly, was I saw zero shell in the nib, none. And these were roasted beans, but just I saw zero. I was astonished, right, at how well it worked. And then when we opened up the cyclone, the bucket under the cyclone, and looked at what was in what was in the shell, the small amount of fines that I saw were, and I saw nothing that I would consider to be a usable nib fraction in there, and almost no dust in the bottom of the bowl. I was astonished. And so, two of the user experience bits, and Jim goes, wow. Yeah. And that was my response immediately, right? Wow. Right. Two of the user experience points that immediately occurred to me. Number one is, I want there to be a mechanism on the vacuum, which is just a plate that you angle, right? So that what you can do is I can make sure that plate I can reproduce a specific angle time after time after time after time. I don't want to have to fiddle with it, right? Which again, and then once I set the distance between the plate and the cracking wheel, what I want to be able to do is I want to be able to hit that distance time and time again. I don't want to have to feel around for it and get it close, right? And I think that these are like two of very, very simple things which can be done, which I don't think any other small cracker on the market tries to do. Right. And so, Jim, yeah, absolutely. You and I are talking about, you have an existing cracker and winter system, which is complete overkill for your business. You're looking to sell it. So there will be a classified up on the Chocolate Life shortly for it. But I think that, you and I have had a very, very quick discussion that this machine is the one that will replace it. And so, the moment this becomes available on the website, you need to go and pre-order it, because I think I don't know of anything. Right, I'm not being paid to have this comment.
No, I'm not paying you.
Yeah, I have not seen anything at this end of the market for this price point, anything close to this price point and this size, right? Which is going to be able to, your competitors, Bhavani, will take this machine and buy it and deconstruct it, right, and try to re-engineer it. As you have said, there's a lot of things having to do with the geometry of all the moving parts that are very, very critical, and that's one of the things that you spent a lot of time working on, right? So it's going to be it's going to be a little more difficult. So right, Jim says they'll be pre-ordering it. Yay. And then Encore, which is at Kansas City, Missouri, not Kansas City, Kansas, says, what are the shipping timeframes for the new Melanger and the new Winnower?
The Melanger is end of first quarter, and the Winnowers, we started shipping on a small basis, like but we're taking orders for the Winnowers right now, but not for the Melanger yet. Melanger is going to come at a later date. But the Winnower, I think beginning of the year, it'll be on, it'll be available to buy and ship within 2 weeks and stuff like that. But right now we're shipping the Winnowers anywhere from 3 to 4 week time frame. Yeah.
Right. So both the Melanger and the Winnower are on pre-order, right?
Right.
So that you can get your hands on one. The normal shipping time will vary because there are aspects of this which still need to put into full production. Right. So, but it looks like the 15 will be available just for ordering on the website and delivery within the first 3 months of next year. The Winnower is further along in some respects, and so you can order it, and it's not going to be like shipped next day, but it'll be shipped relatively quickly. Am I understanding properly?
No, right on.
Cool. That's great. So thank you, everybody, for participating here today. What I will say is please go and visit TheChocolateLife.com. If you're not already a member of The Chocolate Life, please join. You can just click on the join button here or the join button there. There's always a free level of support. I know that everybody is, times are tight, and that not everybody has free resources to be able to throw my way. But I do appreciate it. Your support keeps me on the air. I don't have a Patreon. Everything is done through direct support of The Chocolate Life. And Bhavani, I'm going to give you the next to last word. Is there anything you'd like to say before we end today?
Thank you for your time, and thank you for the questions and the participation and the listening to us talk. It's been awesome. I really enjoyed it. Thank you very much.
So
thank you, Clay.
It's been my pleasure. And before you leave, Kurt asks if anyone has experience with this. And so what I want to say by this is whether it's the Melanger or the Winnower. And the answer is yes, people have experience with them. People are using them, and they're providing feedback on things that can be used to improve them before they go into production. They're not shipping prototypes with known bugs that haven't been fixed. Right.
Correct.
So absolutely yes. So Kurt, I mean, I've worked with some companies that have shipped their first prototypes to customers as if they're finished products. And I can tell you it's not something I ever want to participate in again. And with that, I want to thank everybody for hanging around for an extra 15 minutes. We've gone a little over time. I want to thank Bhavani. Certainly you and I will keep in touch, and we'll let people know as things go on, availability. People can go to the Chocolate Life and keep in touch with all of these kinds of things. And I want to end, as I always end these episodes of the Chocolate Life Live, to remind everybody, if you're working with chocolate and you're not having fun, you're doing it wrong.